All right, this is the Math Models Unit 1, Lesson 3 video over scientific notation. Hopefully this is something that you're at least somewhat familiar with. Scientific notation is a way of writing numbers that are either really long, really big or really small. In other words, that have a lot of zeros and a lot of digits, and shortening them so that they're a little bit more manageable and not so long to write. For instance, this number here in number one is 2,371,875,908. It's like we don't want to always have to know or write that entire lengthy expression. So there's a shorthand, a shorter way to write these numbers. And so I'm going to jump over to an image here to talk about, in general, how this works. So to convert to scientific notation, you're going to move the decimal point so that it ends up where there's just one digit left of the decimal point. So like one right before it, in other words. So any number, no matter how long it is, the first thing you're going to want to do is move that decimal point until you get it there. So let's do that right now. So if I'm here and I want to move that decimal place, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces. So I move 9 to the left. So that's something you need to know. Is like you moved 9 spaces to the left and you end up with 2.37. Obviously, you can see here there's a bunch of different options. They all have 237, but we're always going to have just one number before the decimal. So 2.37 is going to be the first part of our answer. And then because we moved our decimal point to the left, the exponent is going to go up. In other words, that number that we found is going to be positive. So it's going to be times 10 to the 9th. And this is what the final answer looks like. So different parts of this expression. So the 2.37 is the original number with just the first digit in front of the decimal and then 2 digits after. And then times 10, and then there's an exponent on 10. And that exponent is the number of spaces you moved. So obviously in this answer, we're going to be choosing the second answer choice. But here, just to be clear, if I had moved to the right, my exponent would be negative, right? So exponent goes up, positive exponent goes down, negative exponent. So in this example here, 0.000053 becomes 5.3 times 10 to the 6th because we move this decimal 1, 2, 3, 4, 5, 6 to get to that point, and those 6 spaces are represented right here. Let me erase that. Let's clear everything. And let's go back to our lesson. So you're going to be doing that in these examples here. Number 2, number 3, number 4. You need to move the decimal place until there is just one number in front of the decimal, 2 digits, or sometimes more after the decimal. And then the number here on the exponent of the 10 is how many spaces you needed to move to get there. Then starting at number 5, we do it the other way around. So let's look at how that works. Well, here, if I had this number 3.25 times 10 to the 9th, it tells me to take that 1, 2, 3, 4, 5, 6, 7, 8, 9. And notice, once I get past this 5 here, I'm going to add a 0 for every single one of those spaces that I moved, and it ends me up with this longer number. 3.25 times 10 to the 9th becomes this long 325 and then 7 zeros after that number. So that's what we're looking at when we convert from scientific to decimal. And then the other way around is true as well. If I have 4 times 10 to the negative 7th, that is going to go 1, 2, 3, 4, 5, 6, 7 spaces again, but this time back to the left, right? So the number is getting smaller. So a positive number means a very large number, a positive exponent, large number, negative exponent, small number. So that's what we're going to do here. I'll do one of these examples. Let's do this one down here. Convert the number to standard form. I'll do number 6 for you. So we start with 3.76, and we need to move it 9 spaces smaller. So it's going to go this way. 1, 2, 3, 4, 5, 6, 7, 8, 9. And let me erase and start over because I did not give myself enough space to do that. So let's go back. All right. How about 3.76? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 0, 7, 0, 8 zeros ends up. 0.08 of them, 376. So it looks like we've got the correct answer right there. So that's what you're doing in 6 and 5, 6, 7, 8, 9, 10. Okay. And then we get to 11, 12, 13, 14, which are a bunch of problems where you're going to multiply or divide these types of numbers. So I'm going to kind of talk through a little bit about how to do this, and we'll do it 2 ways, and then I'll kind of give you the freedom to choose. But the best way to do this is to actually not multiply them like this. You're actually going to multiply them vertically. So let me show you what I mean. 2.45 times 10 to the 9th. So I should probably try again here. This is a little bit messy. All right. Let's rewrite this. 1.29 times 10 to the 4th times 2.45 times 10 to the 9th. So first things first, each part of this is going to be its own problem. That's going to be a problem, and this is going to be a problem. We're going to combine our answers. So when I do 10 to the 4th and 10 to the 9th together, they become 10 to the 13th. And when I do these numbers multiplied together, I'm going to get something else. So in this case, I think I'm going to, let's just multiply it over here on Desmos. 1.29 times 2.45. Oops, let me clear this out. Clear. How do I clear? Oh, that's why. Okay. Clear all. All right, 1.29 times 2.45. And we get 3.16. So that's what we're getting right here. We have 3.16 times 10 to the 13th. So that's going to be that one there. So notice we can multiply these numbers, add the exponents to make 13, because that's a property of exponents. And we can do these numbers multiplied separately, and it gets us that answer there. The other way to do it, and I'll just show you, is we can just type this in directly. So I'm going to go and just go in and do 1.29 times, let's go back over here, 10 to the 4th. And I use this button right here for my exponent. Oops, sorry about that. 10, oops, let's go back. Let's go back up here. 10 to the 4th. I'm going to start back here. Sorry about that, everybody. 1.29 times 10 to the 4th. Close my parentheses. Times parentheses 2.45 times 10 raised to the 9th. Close my parentheses. Enter. 3.16 times 10 to the 13th. And that is the correct answer that we got. You can do that with the rest of these. This one's going to be division. You can type this entire expression into your calculator on Desmos, and it'll work it out. Let me show you what I mean. 4.5. Oh, come on now. All right. 4.5 times 10 to the 15th. Raised to the 15th. Put a parentheses there. Times, or no, in this case, divided by, let's go back up here, divided by, oh, see, it made a fraction for me, parentheses, 1.5, go down there, 1.5 times 10 to the what? Negative 5th. See what happens there. 3 times 10 to the 20th. So we got there, and there we are right there, 3 times 10 to the 20th. So just be careful about typing those in, but you can definitely type in this entire expression all together into Desmos. You can type this entire expression in Desmos, or you can go add up these and subtract these and then do the other parts of the numbers on their own. But I would recommend for these larger ones, I would recommend go ahead and typing this entire thing in on the Desmos calculator and just making sure that you're being careful. Like I have a little bit of a weirdness here with this negative, but that's okay. So I could type these in and get them to look exactly like what I have here.